In this video, we'll examine how energy can be transferred from one object to another. The classic example of this is bowling. If you bowl and the ball rolls down the alley just before it hits the pins, this is the situation. The pins aren't moving, are they? They have velocity of 0, so they have kinetic energy of 0 joules. Most bowling balls are about 7.5 kilograms, and let's say he's moving at 15 meters per second. Well, I can use the kinetic energy formula, and I can calculate the kinetic energy of this ball to be 850 joules. Now, think ahead for the next slide. What's going to happen when the ball hits? Well, first thing you know, these guys are going to move. They're going to pick up velocity, aren't they? And then you'll know because kinetic energy depends on velocity. These are going to gain kinetic energy. How's this guy going to lose it, though? Isn't he going to lose some? Well, the way he'll lose it is he'll slow down. Now, when you're bowling at the end of the alley, you can't really see the ball slowing down. So it's a ways from you, and you're not looking from the side. But it does slow down. Think of anything striking anything. It slows, doesn't it? So what happens here, let's say the ball was traveling 15 meters per second before, and I made this up. Let's say it slows to 12. He's going to lose kinetic energy, isn't he? In fact, now his kinetic energy, the ball, is only 540. It was 850. He's lost it. Where did it go? It went to the kinetic energy of the pins, didn't it? The total here is the same, but there's a transfer of energy. Energy is transferred from the ball to the pins. 310 joules of kinetic energy is transferred from the ball to the pins. Total doesn't change. That's conservation of energy. So there we go. We see energy being transferred there. It's a classic example. All right, now let's look at another example. You've seen a tee, haven't you? A baseball on a tee. Rather than a pitcher pitching this ball, this guy's going to hit that ball off the tee. By the way, here's your code. You should grab that. All right, now, one interesting thing about a bat hitting a ball is it doesn't strike it for very long. See how the bat comes down here through here, it's gaining velocity, speeding up, but it's not hitting the ball yet, is it? When it does hit it, it's only in contact for a short period, and then the ball flies away, doesn't it? So here's where all the action occurs. Now, there are two ways of looking at this. One is a transfer of energy, just like with the bowling ball. Let's look at that. First, the KE is transformed from the bat, that has it, to the ball. Just like with the bowling ball, the bat slows down. Again, you can't see this probably when you watch someone hit a ball, but the bat does slow down, and the ball speeds up, doesn't it? So the bat loses kinetic energy, transfers it to the ball. Second way looking at it is going back to that subject of work. Remember what work was? Force exerted over distance. Wouldn't you agree that that bat is exerting a force in that ball just for that short distance there in the blue? It does. It does work. It exerts force over distance. It does work. And of course, you remember from before, that work goes into the energy of the ball. All right, so we'll wrap up here by saying that objects can transfer energy from one to the other. Usually it involves, often involves one slowing down and one speeding up. And the second thing is we can look at that same thing as one object doing work on the other object, and thus increasing its energy. Bye.